No. Now, uh, for deciding the current rating, thyristor current rating is very much important. The peak current flowing through thyristor is very much important. The peak current flowing through thyristor is I0, nothing but the load current. ITA peak, this is Vs under root C by L, which we have derived from the previous derivation. This is nothing but Vs under root C by L, that is my IP sin omega naught t, which is flowing to our circuit. This is nothing but IP sin omega naught t. So this is the auxiliary thyristor on, this is flowing through it. Now, the time required to turn off the main SCR after the auxiliary thyristor is switched off. The time required to turn off the main thyristor. So the time required will be, this is nothing but the pi under root LC, same duration pi under root LC. And this is nothing but the T2, which we have find out by this formula, under root LC sin inverse of I0 by IP. Same pi under root LC, under root LC sin inverse of I0 by IP. This is the time required to turn off the main thyristor after auxiliary thyristor is switched on. This is important. Let's see further. This is pi under root LC and this is the T2. Pi under root LC plus T2, and T2 we find out, T2 is under root LC sin inverse of I0 by IP. Same here, pi under root LC plus LC sin inverse of I0 by IP. For the minimum time required to turn off the main SCR, the minimum T minimum is nothing but the, we can turn off the thyristor at this point only also. So this is pi under root LC. Minimum time starts from here and maximum time up till here. Okay. And after that, the maximum time required to turn off the main SCR. Maximum time is nothing but in this I0 by IP. The sin inverse of I0 by IP is, when it is 1, it will be pi by 2. So pi by 2 under root LC. Pi root LC plus pi under root, because maximum is 1 when I0 equals to IP. I0 equals to IP means this is 1. Sin inverse of 1 means pi by 2, and pi by 2 under root LC, 3 pi by 2 LC. This is the maximum time. If I0 is greater than IP, then commutation is not possible. So I0 will be less than or equal to IP to make commutation possible. Let's see this point. If suppose I0 is greater than IP, then commutation is not possible. We have to make commutation possible. We have to satisfy this condition that I0 should always greater than IP, so that I0 catch IP and make commutation possible. See, this I0 make, due to this I0, this current is going to 0. When that I0 equals to IP, that ITM is 0. So I0 should always be greater than IP. IP, that is the peak current flowing through auxiliary thyristor. The maximum reverse bias voltage across the main thyristor when it is in off state is VR under root Vs cos inverse of sin naught by IP. As we have seen that here, as current is 0, main thyristor current is 0, the reverse bias voltage is applied across the thyristor. This is the reverse bias voltage and duration is TCM. That is the reverse bias voltage which we discussed. Vs cos sin inverse of I0 by IP. And last point, circuit turn-off time of main thyristor is TCM. TCM is nothing but the time at which reverse voltage applied across the thyristor is CVR by I0. That is very important formula. TCM is circuit turn-off time. This is safe value. Safe value in exam we always take greater than 1, most probably 2, and TQ is the thyristor turn-off time. So from this we can calculate that circuit turn-off time is always greater than thyristor turn-off time. Okay, next one. Now here some questions. What is the need of diode? What is the need of diode in this circuit? What is the need of diode in this circuit? If we can't connect diode now, the auxiliary thyristor is of no use. We can't have any control in this auxiliary thyristor. So diode is very much necessary, and diode has diode has its own importance. Second question, this is the IS question. Check whether in this circuit commutation is possible or not. So the question answer is this: two anti-parallel devices can't conduct simultaneously. Two anti-parallel devices can't conduct simultaneously at a time because voltage drop across conducting device applies reverse voltage across device D2, and D2 can't conduct in second mode because main thyristor is already in on state. So our question is, this circuit is not working because the voltage drop across this thyristor apply reverse bias across D2, so this will be turned off. So this circuit can't conduct in second mode. Okay, now important gate problem which are came in a commutation circuit employed to turn off a satisfactory turn on is obtained when this is the condition which we already discussed. Circuit turn off time is always greater than device turn off time, which we already discussed in this point. This is the point. Circuit turn off time is always greater than thyristor turn off time. Okay, and safety value is always greater than 1. Now next, this is also one question which came in gate. In this figure they are asking the minimum and maximum turn off time. The auxiliary thyristor trigger and THM is turn off between maximum and minimum time. In this circuit, this is nothing but the class B commutation diode. The beauty of this circuit is that the question is confusing. In our circuit, thyristor is here, diode is here, but in this diode is here. Let's see. In this diode is here. In this diode is here. Sorry, this is not thyristor. This is diode. Make it correction. This is diode. In our circuit, diode is here, but in this diode is here. So we have to find minimum and maximum time. T minimum is equal to pi under root LC, which we already discussed in our formula list. T minimum is nothing but pi under root LC. So we have to find the duration of time between which thyristor is turned off. Duration of time. So we have to go through that graph diagram. Duration of time TC minimum, it will turn off here up till here. So this is the time, minimum to maximum time. This is minimum time, pi under root, this is maximum time, 3 pi by 2 under root LC. So T minimum pi under root LC pi L, which is going to 10 microfarad. Inductor 25.28 10 to the power minus 6. 14.95 microsecond, nothing but 50 microsecond. T max 3 pi by 2 under root LC, 3 pi by 2 pi. This is L, C 75 microsecond. This is the problem of gate 2007, 2 marks, and this is a problem of gate 1998, 1 marks. Okay, thank you, sir. Thank you.